welcome to my channel Concept Learning. In this channel, the first concept that I am going to teach is 3D geometry. The reason why I chose to teach this topic is because many people feel that 3D geometry is difficult, but believe me, it's so simple. So if you don't believe that, I'll make it for you. So you did not hear about 3D geometry till now. You will get introduced to this topic only in the first year, right? But you have already been familiar with 2D geometry. So what is meant by 2D geometry? In 2D geometry, we will discuss about line, point or anything that is on a plane like a board, paper or any plane like that. But in 3D geometry, we are going to discuss about a point or a line that is in the space. So what did I say? Point or line in the space, right? So if I speak about that point, the first thing that it should come in your mind is imagination. So how well you do 3D depends upon how well you imagine the problems or the concept. Okay, so let's get started. So when I speak about a point in 2D geometry, how do you represent it? You represent it using x and y axis, right? So if you want to represent a point in space that is in 3D geometry, then how are you going to represent it? So you will use x and y axis in common, but to represent a point in space, you will add another axis, that is z axis. So I have made an ideal axis for you, that is this. So this is x axis, this is y axis and this is the z axis. So if I want to describe the position of a point over here, I am going to take these axes as reference and I am going to measure the distances of the point between these three axes and I am going to tell the point position. Okay, so now in 2D geometry, this is x-axis and this is y-axis. So if I want to tell the position of this point, I am going to tell it as x1 comma y1, right? So coming to 3D geometry, if this is y-axis, this is x-axis and this is z-axis. If I want to represent a point in the space, so I will put it over here and I will represent it as x1 comma y1 comma z1. So I am just going to add another coordinate, that is z, because we have added the z axis. Okay, if I take the x axis, y axis and the z axis, so if I want to represent a point on the x axis, I will tell it as x1 comma 0 comma 0. In the same way, a point on y axis is 0 comma y1 comma 0 and a point on z axis is 0 comma 0 comma z1. So here the x1, y1 and z1 are variables. Okay. So now in 2D geometry, if this is x and y axis respectively, if I have 2 points, one x1 comma y1 and another point x2 comma y2, how do you find the distance between both those points? Yes, we have distance formula for that, right? So what is that formula? It is x2 minus x1 whole square plus y2 minus y1 whole square, right? So in the same way, in 3D geometry, if you want to find the distance between any 2 points, what we do is the same thing, but we are going to add another coordinate, that is z. So if this is x, y and z axis respectively, and I have points x1 comma y1 comma z1 and another point x2 comma y2 comma z2. Now if these 2 points are in space, how do you imagine them? One is here and one is somewhere around there. Okay, so you must just imagine the points. Okay, so if I want to find the distance between these 2 points, what do? I will just write the formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. The same formula repeats, but the only added term is z2 minus z1 because of the z coordinate. So now in 2D geometry, what do? You give a point somewhere here, that is x1 comma x comma y, and if I ask you to find the distance between the origin and this point, what is the formula that you use? You will use root of x1 square plus y1 square, right? So in the same way in 3D geometry, if this is x, y and z coordinates respectively, if I have a point over here x1 comma y1 comma z1, to find the distance between origin, that is 0 comma 0 comma 0, and the point, the formula that I use is x1 square plus y1 square plus z1 square. The same thing. Okay, so these are the distance formulas. In 2D geometry, you will also find something called section formula. So what do you use the section formula? What do you do is, you will take a line and there are points x1 comma y1 and x2 comma y2, and now you have another point between them, that is some x3 comma y3. Okay, so if I say that this point divides these two in the ratio m:n, then you will use the section formula, right? So in the same way in 3D geometry, if I do the same thing, then what will happen? I will just add another coordinate, that is z1 and z2, and here it will be z3, right? In 3D geometry, now how do I write the section formula over here? To tell the point x3 is equals to nx1 plus mx2 by m plus n. In the same way, y3 is equals to ny1 plus ny2 by m plus n, and z3 is equals to nz1 plus mz2 by m plus n. So the same section formula we use it over here. So if you do it, if the point cuts externally, that is in this way, if there are 2 points over here and this point cuts externally, then what do you all do? You just put minus in all these places, right? So this is the same section formula that you know in 2D geometry, but the only thing that we add over here is this z3 term. Okay. So now there comes another new one that is not related to 2D geometry. This is the new concept that comes in the 3D geometry. That is nothing but DCs, that is direction cosines. So now what are these direction cosines? I will tell you. So if I take this ideal axis, this is x, y and z axis, right? So if I take some line, let me think this is the line, okay? This line joins the origin to some point x1 comma y1 comma z1, okay? So this is a long line, extendable line, okay? So now this line makes some angles with these x, y and z axis respectively, right? So how do I represent it on a board if I want to? If this is y, x and z axis respectively, so if I take a line over here, some line that joins the origin to an extendable line, so now this line makes some angle with x axis, that is alpha, and another angle beta with y axis, and some other angle gamma with the z axis, okay? So if these are alpha, beta and gamma angles, so then if I apply cosine to all these angles, that is cos alpha, cos beta and cos gamma, Now these three will be called the DCs of the line. Remember, of the line, only a line has DCs. Okay. So now I can represent them as L, M and N. Generally we represent those DCs with L, M and N. So with this we have a small relation with this using these DCs, that is L square plus M square plus N square is equals to 1. Okay. So through this what do we get? Cos square alpha plus cos square beta plus cos square gamma is equals to 1. Okay, this is a relation in cosine. If you want a relation with sine, you can also do that, because you can write cos square alpha as 1 minus sine square alpha plus 1 minus sine square beta plus 1 minus sine square gamma is equals to 1. So now if I add all these ones, what do I get? 3 minus of sine square alpha plus sine square beta plus sine square gamma is equals to 1. So if I exchange these places, I get sine square alpha plus sine square beta plus sine square gamma is equals to 2. Okay. So these two are some important relations which will be useful for you in your competitive exams as well as in your IPA exams. Okay. So now we have talked about DCs. Now another concept, that is DRs. DRs is very simple, not so complicated. That is, what a DRs actually is, this multiples of the DCs is known as DRs. That is quite simple. DRs are direction ratios. In the name itself there is ratio. So the multiple of DCs is known as DRs. So for example, now if I take a pair of DCs like for example L comma M comma N. Okay, this is general form. Okay, so if I want to write DRs for this thing, I can multiply it with anything like 2, 3 or any number. Okay, so example 2L comma 2M comma 2N. This is one pair of DRs, and 3L comma 3M comma 3N. This is another pair of DCs, and I can also write minus L comma minus M comma minus N. So anything, any M, you can put any rational number, but it should be the multiple of this DRs. Okay, so for one pair of DCs there exists infinitely many number of DRs. Okay, so what I know how to write DRs if they give me DCs, but what if they give you DRs and ask you to write DCs? Then there's a small formula for that. So if A comma B comma C are DRs of some line, okay, so then what will be the DCs of this line is plus or minus A by root of A square plus B square plus C square, comma B by root of A square plus B square plus C square, comma C by root of A square plus B square plus C square. So this is the formula. Now what are these plus or minus? Okay, sorry, I have forgotten to write square. Okay, so what is this plus and plus or minus? So we have two pairs of DCs for one pair of DRs. That is one with plus sign and the other with minus sign. Okay, so for each pair of DRs there are two pairs of DCs. Okay, so that is a simple concept. Okay, so for today that's all. So in my next class I am going to teach some more new topics in relation with lines, planes and all the others. Okay, thank you for now. Meet you in my next class. What are these plus or minus? Okay, sorry, I have forgotten to write square. Okay, so what is this plus and plus or minus? So we have two pairs of DCs for one pair of DRs. That is one with plus sign and the other with minus sign. Okay, so for each pair of DRs there are two pairs of DCs. Okay, so that is a simple concept. Okay, So for today, that's all. So in my next class, I am going to teach some more new topics in relation with lines, planes and all the others. Okay. Thank you for now. Meet you in my next class.